Okay. So far, so good. It's the same as before. So spread out so you're like one per table. Okay. Right.
Yeah.
Keep the rank of the written part, not the multiple choice. I'm just thinking the question. No, I just want to. We're not. Okay. I just have a question on it. Oh, like part of the.
Okay, good morning. Nice to have you all live. It's Sunday without mask. Look at this. I got people here too. Good morning, Bella, and good morning, Oscar. So theoretically, I'm not supposed to be live streaming, but just don't tell anybody and all will be well. So I'm doing a demo here, which I'll show these two as well. I've got some distilled water, and I'm going to put in something we don't often use in AP Chem, and that's universal indicator. Who remembers the color? If universal indicator is in an acid, do you remember what color it is, Errol?
Red, yellow.
There you go, red for the most part. What about if it's in a base? Louisa, blue, super. And if it's neutral, so fairly close to this, it's what color? Green, yellow. So let's see what it is. With a good batch, it's yellow. Seems like I had a problem this year. It was more orangey. Let's see how it looks today. Okay, it's pretty yellow, actually. Let me show that to our studio audience, no, our at-home audience. So there it is. I'm going to swirl it a little bit, but it's definitely yellow. That's like a good yellow. That's like a classic yellow. Okay, so it's pretty close to 7. That's distilled water right now, right? You'll see why I'm doing this in a sec. So what I'm going to put in this, make sure they can see. So it was yellow, with just water in it. Now we're going to add some, what did I grab? I hope it works. Some sodium sulfate. Sodium sulfate. Folks at home can do this too. I want the formula. What's the formula letters for sodium sulfite? See if you still have the ions memorized. That's going to be this stuff right here, sodium sulfite. And Sophie. Yes, good job. So sodium, Na2, and SO3. And she's right, it's SO3 because that's sulfite. Sulfate is SO4, but they're both 2 minus, so she has put 2 NAs attached to it. Super. If you can do that, that's good. So we're going to put some of that in there and see what happens. And then try and, well, I hope it works. find out here. I'll try and do it where everybody can see it all at once. So right now it's yellow. And should it be soluble or not, this stuff? It should, because what's it got in it? What's soluble that's in the formula? Anthony? Sodium, so very soluble. Okay? I know, it's another item, but you should know all that chemistry. So here it is. Tell you what, I'll just do this. Hello, Alex. Whoa! Check that out. Pretty major thing. So it's definitely on the side of things now. It's on the side, Feeny. What is it now? A base. Okay, it's a base now. Okay, so it's turned blue, decidedly blue. Whoa. So let's find out what's going on. Will this be, is this acting as a strong or a weak base? Hint, the color's not going to help you. Weak, because it's not one of the strongs. So before the AP test and like clausura, you got to memorize the strongs. So weak because it sounds sort of stupid. It's not the strong ones like OH, NaOH, CaOH2, blah, 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 blah. Anyway, those are in the book, know them. So it's a weak one. So it's a weak base, and that's what we're working on today is weak base problems. And from the formula that Anne-Sophie gave us earlier, what will be the spectator? What do I not have to worry about when I write this reaction? Na2SO3, what's the spectator? 2, 3 people know? All of you should know by this time of the year. It is Lycia, Na+. You have to memorize those spectators. So the one that matters is SO3 2-. So what we're writing is the net ionic reaction. Remember, leave out the spectators. So I got SO2, SO3 2-, that's aqueous plus water, H2O liquid. And you know it reacted with the water because there was nothing else in there, right? I'm going to make double arrows. And let's see. Hopefully these guys can see still. What's going to form? What's going to form? We did this sort of thing last time. Arrow?
I mean, because the base form, but it's going to be SO3 OH2. And then base
Well, careful. That's negative. That's not going to combine with the OH, right? So do it the other way, Arrow. Remember, water, everybody's made of what? Everybody, it's OH minus and H plus. So think of water that way from now on. So what's it going to grab? Make it grab something. What's the SO3 2- going to grab? Aiden?
The one hydrogen.
A hydrogen, right. So let's do it. H, SO3. Now what charge will be on it once it's grabbed the one hydrogen, as Aiden said? It'll now be, Chelsea, minus. You might say, Mr. Weiss, want to grab 2? Well, maybe, but normally we're moving one proton around, just one. And frankly, it's a weak base, so it may just be grabbing 1. And then, because it's grabbed the H plus, now, Arrow, what's left? There you go. And that, my friends, is making it a base, a weak base. That's where we get that blue color from. Anthony.
No question on
These should be of the phase changes. Aqueous, liquid, aqueous, aqueous. Normally you don't unless they're asked for. So unless you're asked for the phases clearly on an AP question, you don't have to worry about it. I do it because I know where we're going, and that is we're going to do a KB problem right now. So where we left off last time, everybody, is we did a weak acid problem. Well, today we're going to do a weak base problem. I hope to be able to finish this up and then have some time for your questions, especially in the second period. But let's finish this unit now. I got a hammer with you because I want to get through the other acid unit and ideally through our last chapter before Easter break. Whew. Okay, plus I want to get a lab in, which we'll try and do in one period tomorrow. And while we're doing that lab, I'd like to grade at least your chapter 1, let's say, out of your book 2. So please bring your books tomorrow, your book 2. Not book 1, just book 2. Book 2. Book 2, not 2 books, book 2. Okay? Okay, here we go. So I'd like to find out what the pH is of this. So I'm going to make up something. I don't know what concentration I made it, okay? So let's make some guesses. Okay, example. Me. Can these guys still see that? Not really sure. Hey, remember, let's get the chemicals put away. So I knock those over again. At halftime, too, I've got your labs here from about 1,000 years ago that you can have back. Okay, so, and I'm guessing I put in maybe about 1 gram of the sodium sulfate into, and actually that's pretty close, into 250 milliliters. Now we're going to assume no volume change. What do I mean by that? Assume no volume change, Anthony? Right, we're going to assume it stays that in spite of the fact that I threw in 1 gram of this stuff. That quite often in the AP they'll say that, no volume change. The Ka for, ooh, now I got to look in our book. I think it's 477. Does that ring a bell? No, maybe 377. I'm looking up the Ka. You might say, but Mr. Weiss, this is a Kb, but your book doesn't have Kbs. So I can look up a Ka, and that's okay, as it turns out. Okay, where'd you put them? I should have marked it, but I don't think I did in this book. Somebody else finds it, let me know. I need the list of Kas. No, it's in chapter 5. Sorry, screw up. Thank you so much, Penelope. 277, dynamite. Way different than what I marked. Super, look at that. I had a mark. I got a stupid teacher. Anyway, okay, so I got it there. Thanks to Penelope. So what Ka do you suppose I'm going to look up there? What acid would be the conjugate acid for this sucker? So there's my pair, right? Which one is the acid? Which one am I going to look up? Which one's the acid? Alex, which one's the acid? You got it. So I got to look that up in a second. Quick nose blow. And away we go. Okay, so There it is. I got H2SO3, but I think it's the other one. I think it's HSO4 minus. So the bisulfate ion. And the Ka is 1.2. So the Ka equals 1.2 times 10 to the negative 2. This is like the worst chalk. Who bought this? It's terrible. I'm amazed these poor people at home can see anything. I can't see anything very clearly. I'm trying as a fellow. I'm trying to. I'll get as close as I can without my laptop falling over the place. Okay, so I got to the Ka, and it's 1.2 times 10 negative second. We got a reaction already. So we're going to say, I'm going to get the Kb. Did I teach you that little trick yet? I think I did. If I got the Ka, how can I get the Kb? Maybe I didn't teach it to you. Okay, here's how you get it. This is cool. Ka times the Kb equals the Kw. But you know that number. Anybody got it memorized yet? What's the Kw number, Penelope?
1.0
Well done. So what that means is I can find the Kb every time if I got the Ka, which they often do on the AP test. So throw it in and life is okay. 1.2 times 10 to the negative 2 times the Kb. And everybody at home and here in the classroom, grab out a calculator, please. And let's punch that out and agree on the Kb. It's a big thing. Okay, so try to get the Ka from the Kb.
The KW is always just a constant.
That's a constant. So that number you really want to memorize, Aiden, because it's the same every time. Yeah. Is that right, Anthony? Okay, others got the same? Thank you for checking. Super. So we got the Kb. Now, did I ask you a question about it? Well, that was sort of dumb. What I want is the pH. So put a pH and a question mark. And now we can actually do it as a Kb problem. Okay, so I'm going to change boards. And here we go. We have, folks, the expression already. You know what? Maybe I won't change boards yet. Let's do this. Here's my reaction. So, give me the K. Who haven't I talked to really? I haven't talked to. I talked to Errol. I talked to. Okay, Aiden, you want to just give me the KB expression? What's over what here for this reaction up at the top?
That's those three, the concentration of those three
Minus, right?
oh yeah.
Times?
And the concentration of OH minus
Good.
over the concentration of SO3. Yeah, it's minus the concentration of, but you don't have the issue.
Right, because it's a liquid. Super. Thank you, Aiden. Okay, so Aiden's given us the K expression. It's 10 Bella, it's 10 to the 14th, minus 14th. The Ka times the Kb equals 10 to the minus 14th. That's how that works. That'll be in Cheryl's book somewhere too. Okay. Now, let's see what we've got. We want to know the pH. If we found this, that'd be cool, but we don't have that. Did I do this right? I got the KP. Yeah. We did this, okay. Okay, you ready? So now, and Sophie,
I think it's 10 to the negative
17?
17.
You did. Thank you. Then I didn't hear you right. Okay. Which is pretty small, right? So it really is a weak base. Good. Okay, so let's do it. Let's remind ourselves. This stuff, the SO3 2 minus, that came from which chemical? Where did that come from? Just so I know you're following. Chelsea? Okay, so you know what? I got to remember that that's this stuff. Now, I need the concentration of this, and I can get it. I need it in moles per liter. I gave you that I got 1 gram in 250 milliliters. Somebody just say it. What are we going to have to do to get the concentration? Anthony, how about a sentence? And? And then divide by the? No. We're converting the grams to moles and then divide in by the volume. So we got, remember, we're going, Anthony, for moles per liter. So at the end of the day, you got to divide by liters. Okay, let's do that. Okay, here we go. So 1.00 grams, well, 1.0, I think I did. Na2, SO3, because that's the stuff I think Chelsea said it came from. So I need to then change that to moles. Let's do it. Can you guys find the molar mass for that, please? 2 NAs and an S and 3 O's and add it up. The back of your book has your periodic table. (8.3 times 10 negative 13). My folks at home have something different. Let's make sure we're doing this right. So I got, I don't think it's 17. Can everybody do that again?
8.3, that's 8.333 to the negative 13.
Yeah, I think it's 13. You guys, somebody, you tell me, raise your hand. That's why I gotta do that. Okay, so Oscar, yes, that's right. And Bella, yes, that's right. So it's 8.3 times 10 negative 13. Thank you, and thank you guys. Thanks to folks at home for catching that. Everybody say something. That's why I have everybody punch it out. Yeah, 17 wouldn't make any sense. So I got to divide this by that, which I'd make some of it cancel. So I should, or this by that. So I should have a slightly smaller power. All right? Okay, so what did we get for the molar mass? Somebody got it cranked out yet? Yeah, Penelope. 126.05, let's call it 0.1. Okay, others get the same? Yes, thank you, good. So can you divide that? So what would it be, 0 point something? 1 divided by 126.1. And let me know what you get. Let's see if folks at home can still see that. Yes. Yeah, that's still there. Okay, and Sophie, what'd you get? I need one more sig fig though.
No, you're 7.9.
7.9. I can't hear very well. Does that look right? Okay, so folks at home, 0.0079, and that would be now moles. Now I can write the whole thing, or I can just say what I care about. It's moles of SO3, 2 minus, isn't it? Because we said the spectator ions are the Na pluses, so I don't really care about them, right? We okay with that? Okay, then let's divide it by liters. So 0.0079 moles SO3 2 minus divided by, mentally change it, it would be how many liters, Alex? Thank you. And now crunch it out, everybody, and let's see what we get for our concentration of the sulfite ion. Yes, right, Bella. A little bit louder, Anne-Sophie.
0.032.
Thank you. Let's see if that checks with others. Yes, thank you for checking. I put a big M. I put the chemical enough times, so let's just move it up. And now let's put it in here to the expression I got from Aiden earlier. The KB we know now. So here we go. Bring that down here. So the KB is 8.3 times 10 to the negative 13 equals, this time I know the bottom, don't I? That's the concentration of the ion. So that's what we just got from Anne-Sophie, 0.032 molar. What about the top? My original reaction is there. What about the top? Here's my expression. That's what you need. What about the top? I don't know that. I don't know that. What are we going to have on the top? Because I don't know that and I don't know that. Alicia? No. These are not all the same. This is going to become this, but not totally. Not totally. If it was totally, you're right, it's going to be the same, but it's not totally because I got such a wimpy KB number. Well, what about these two numbers is what I'm really trying to say. Hence, I'll be right with you, Anne-Sophie, but I don't have enough people with me. For every one of these that reacts with water, I get one of these and one of these. You see where I'm going now? Anne-Sophie? Water, no, water's a liquid. There's no concentration even in there. There's no water in there. No, guys, what about these two numbers? See if somebody at home knows. No. Yes, is Bella, you're close. You're close. Aiden?
It's the 1 to 1.
Yeah, therefore, what am I going to have in the expression? Similar to what we did with KA problems last time. I'm going to have?
So it'd be just like something squared.
Yeah, like just what squared?
Like half of it squared?
No. Bella knew. X. It's important all of you think about that. That's a real key to understanding this. For every one that reacts with water, I get one of these and one of these, X and X. Okay? And it's X and X, so then it's X times X squared. Something similar we did last time with the KA problem also. Questions before we go on? Anne-Sophie, then Anthony.
Yeah, I still don't know how you got
Put this in parentheses and then divide it by this in parentheses. And I swear it better be to the negative 13. Try it one more time. Anthony? Yes, please do so. So go ahead and solve for X. And Anthony, let me know, divide this by, no, let's see, we'll multiply, right? Multiply 0.00032 times this sucker, then take the square root. Let me know, Anthony, what you get. And we'll check it with arrow in a second, too. Like that? 1.6 times 10 negative 7? Errol shaking his head, yes. Good. So you guys got the same thing. Let's put a molar on that because now it's a concentration, isn't it? Because we solved for a concentration. And think of where we're going. I know it's taken a while to get there. We want to get pH. What do I have now that will help me get closer to that? That's the concentration of X, which is what thing in my expression that will be helpful. Let's label it as such. So it's a concentration of what? Remember, these are the same. Which one do I care about? Which one do I care about? Entropy? No, I don't care about that. OH minus. Because I want to know that, and I do now. And now I can get the, I want to get pH, but first I could get what? I want to get pH, but first I could get what? Maybe folks at home know. Yeah, you're right on the path there. So Bella and Oscar, I want to get pH. What can I get with this now? I can't get pH directly. I can get what? POH. Remember what that is. It's just the negative log of the OH minus concentration. Hey, beautiful. I got it. I got it. I'm getting closer, so everybody do it. So it's a negative log of this number, 1.6 times 10 to the negative 7 molar. And the POH is what? Exactly, Bella. Good. Keep going, Bella and Oscar. Give me the POH with your calculators, everybody. And let's check. 2 people got it. How about Ellie? You got that crunched out? And if so, let me know what you get. You're still punching. Okay, we'll check it with you then in a sec. So how about back to Anthony? Do you have the POH? 6.7. Ellie's nodding. Thank you, Ellie. And thank you, Anthony. 6.7. Is that rounded? 6.8. Thank you, Penelope. Okay, good. So we're 99% of the way there. Look at what I wanted. I wanted the pH. Somebody take me the last percent. So you got the POH. What was the deal? I could get, Alex, the pH how now? Yeah. So, thank you. Can you do that mentally, Alex, just for grins? Thank you. So it's only very slightly basic, isn't it? Interesting. Only very slightly basic. And yet I got a blue color. But then again, that stuff changes right above 7. So there you go. Okay, and really, we don't really care about universal indicator. It's not on the AP test anyway. But a lot of students have it in 9th grade. That's why I do it for this demo. Yeah, now that's a lot of work, but I showed you several tools I need you to know. I need you to know if you get the KA, you always can get the KB, and vice versa. I need you to know if I got POH, I can always get the pH, the last little tool. And I need you to know, kind of like the Ka problems, we end up with an x squared at the top, like we did last hour with a weak acid. Anthony. Yeah, turns out pH plus the POH equals 14. And the reason for that, Anthony, is that the concentration of H plus times the concentration of OH minus is always 1.0 times 10 to the negative 14. So it's like they took this, Anthony, and then they took the log of both sides, so to speak, and so they get 14 out of this, and then they get, instead of adding, instead of multiplying, these are added. It's the log rule in mathematics. Because to be honest, even though you learn about POH in this class, most of the world uses pH as a standard to report to others. So frankly, a lot of non-scientists still understand pH. So most answers in the world are given as a pH. That's why. Ute, questions from you on that? Okay. That's lovely. That's lovely. Let's now change gears, and we're going to do something similar to what we did with this. We're going to predict check and see if these guys have any questions. Okay, so predict the effect of a salt. And of course, we know now there's lots of salts, right? So not just NaCl on pH. It sounds hard because there's lots and lots of salts in the world. Turns out it's not so hard once you remember that kind of killing me today. Once you remember that spectator ions don't affect pH. So, you ready? Here we go. Let's just list them, and you'll know which ones I want you to memorize. So, from the strong acids, we've got what spectators? And from the strong bases, I got what spectators. Okay, let me start you off so you know what the heck I'm talking about. Give me, Louisa, give me a strong acid or strong base formula. Which one you know? Any strong acid or strong base. You need to memorize those. No. HCl, super. So HCl, let's go, that's a strong acid. So what's the spectator out of the acid she just gave me? HCl is the acid. What's the spectator out of there? Arrow?
Yep.
Cl with what charge? Minus. There ain't no Cl. There's only Cl minus. See what I'm saying? Okay, give me somebody else a base, a strong base you know. Penelope, go ahead. Good. So then the spectator out of that will be which thing, Penelope? Sodium. So Na plus. You see how that works? So Na plus doesn't affect the pH because it's from an acid, or from a base rather, that totally breaks up. It totally dissociates. Cl minus doesn't affect the pH because it's from an acid that totally dissociates. Only the H plus matters. Over here, only the OH minus matters. So if you think about it, it does make sense. Give me another strong acid or base, somebody. Either one. Anthony? HI. Then give me the anion. Thank you. Good. Ellie. Sorry, you just got to say it one more time. CaOH2 minus. Good. Or CaOH2. So it'd be Ca2 plus. Super. Right. Good. We still got a few more. Think of any strong acid or base and then take the one that does nothing out of there. Chelsea, you got another? Yeah, HNO3. So therefore the anion will be good. Now we're cooking. We're halfway there. There's 6 strong acids and 6 strong bases. So I should have another 3 and another 4 over there. Got another one, Aiden. Yeah, so out of that, we're just gonna say, let's see how I've always done it from my list. Okay, we're just gonna say SO4 2 minus. It's not perfect, but yeah, and it's anyway. Well, okay, let's just keep going. What else do we got? Penelope. BaOH, good. Or BaOH2. So then I got Ba with the charge 2 plus. Right, exactly. Three more, and then 2 more over here. Got another one, Alicia. KOH, good. The cation would be? Okay, nice. How about any of you folks at home? HNO3 and NO3 minus, did you already get that one? We did. Sorry, Bella, you had that and I didn't write it down. Strong base example, KOH, yeah, super. And you're right, Bella. Bella or Oscar, you got any of the other 2 bases or the other 2 acids? And Sophie? Good. Good. The cation will be? Good. Okay. We got 1 more base, 2 more acids. Alex?
HClO4.
HClO4. Good. So ClO4 charge on it, Alex?
ClO4.
Must have what charge?
Plus.
No, that's the H plus attached to it. Minus. HClO4, so H is the plus, so ClO4 is the minus. That's the anion. Huge. 1 more of each. Let's see if folks at home. Yeah, Bella got one. And I remembered to look. Good job, Bella. Okay, so she says strontium hydroxide, so it's Sr 2 plus. And we got 1 more strong acid, which is in the same family as Cl and I. Hint, hint, hint. 2 people know, 3 people know, 4 people know. What is it? Okay, Chelsea? HF, no, actually not. It's in the same family, but that one's a weak one. I kind of steered you wrong. But another one, Anthony? HBr. So the anion would be what, Anthony? There you go. Okay. For everybody, do you see why I've hammered you for months about the charge? The charge really matters because it sometimes affects which thing it grabs from the water. Or in this case, which thing it doesn't grab from the water. So all of these do nothing. They don't affect the pH. What that means is everything else does something. That's the thing. And that's the cool thing. Good. Thank you, folks at home, too. Okay, so, sorry, everything else, all the other ions, affects pH. Everything, okay, ions I'm talking about, okay? Let's have you try this. You ready? Ba-da-ba-da. Okay, so chemical. And we're going to do the cation, anion, and then pH. And we're going to just say acidic, basic, neutral. Okay, here we go. So, ba-dum. I'll list these off for the folks at home in just a second. This one, interestingly, is about our lab tomorrow. We're gonna physically measure the pH of this sucker tomorrow. Okay, now, folks at home, I'm going to move you so you can see that, I hope, better. Let me list them off for folks at home as well. So I got chemical, cation, anion, and what's the effect on pH? Okay, will it be acidic, basic, or neutral? And the chemicals, I got NaCl, NH4I, ZnNO32, KCl4, and Na3PO4. Good. For the first one, NaCl, how about Ellie? Give me the cation and the anion for NaCl. Thank you. Now look at our list over there. Somebody else, what can I cross out? What will not have an effect on the pH of these two cations from Ellie? What will not have an effect on the pH? Alex? Anything else? And Sophie? Oh, so neither one affects pH. So if I add table salt to my water, well, don't do that at home because then it tastes salty. What's the effect? I get a solution that's just what? We'll do some more interesting ones after your break. We'll do more interesting ones after the break. Okay, folks at home, any questions while we're gathering up here? Let's see. Are you folks any questions? How about some homework now? You want to help me down here? Look at that. It's all attached to it. Actually, physical papers. I want it. Wow, couldn't find it. Okay, good.
I think he's actually do that for now.
Well, then we're gonna get the okay. Okay, good. Let's see. Okay, today's the 10th, right? So the ions on the right are all the ones that are spectators, right? Yes, Oscar. They're the ones that don't affect the pH. So whenever you see those are ones you can kind of ignore, and then the other ion is the one that does something. These guys are all ignorable. Okay, today's the 10th. You're welcome, Oscar. And Oscar, tell me when you're ready to Google Meet again. All right, you let me know. Okay, so I'm missing Lola. I'm missing Yeah, absolutely. Yeah, let me come over to you. I might have looked up the wrong one because in my old age I got senile and I looked up something up here. So here's H. What did we have?
We had the.
Oh, I looked up because I looked up the wrong one.
Okay.
So you can just put a little note on the side. Yes, but wrong one for Mr. Weiss. Good catch. Great participation today. Good job. Thank you. Okay. Okay. And for the problem we did earlier, gang, with the sulfite, I grabbed the wrong number. So the method is fine, but the number won't be actually right, but it doesn't matter. The method is fine, but I grabbed the wrong piece of data on the chart. So don't take it personally. Okay, but the method is fine. You can still use that. Okay, let's get back to what we're doing. And yes, send me a suggestion, Oscar. Send me a suggestion or two, maybe a couple options, and I'll write you back. Okay. But let's do the next one. Feeney, give me the cation and the anion here. Either of those that I could cross out, Feeney. Just look and see. Are they over here from the strong acid or strong base? It's not hard. Ah, this one, my people, will do something, won't it? Let's see if they can still see. Let's do a little column over here. I'll write think. Okay, this one did nothing. For this one, I got NH4 plus And now what is it going to do? Okay, and Sophie, or do you have a question? Well, that's my question. So we're going to add it to water. And remember, everybody think of water being made of what two things? What two ions? Louisa? Good. Which thing will the NH4 plus grab? You got it. So I get NH4OH. Does it really exist? Yes. Plus, because I run out of room here. And then what's left from the water, Louisa? Ah! And therefore, back to N sub phi. So it looks like that will make the solution what? This is my proof. Penelope, it's going to be acidic. So if it grabs onto the OH minus N sub phi, what happens is the one that's left over then affects the pH. Okay, so it's going to be an acidic salt. Acidic salt. Or acidic solution, however you want to say it. But the way chemists say is, oh, that's an acidic salt. So if it's added to water, I get an acidic solution. Okay, now, how about Oscar and Bella? Can you give me the cation and the anion for this one? The chemical again was ZnNO3 2. Ah, and a question from Oscar. Why would that be acidic? Okay, Oscar, I want to make sure you guys can see this. So just a quick recap. The I minus didn't do anything, so I'm going to take Oscar, the NH4 plus. I'm going to drop it in the water. Water is made of OH minus and H plus. And as Louisa told us, that's going to be attracted to the, I'm missing a plus there. No, I'm not. I guess I had it. The NH4 plus will grab the opposite charge, Oscar, the OH minus. And then this one is left. That's why it's acidic, because it's left over. Leftover H pluses. Okay, from Bella, the cation is Zn2 plus. The anion is NO3 minus. Good job. How about then for everybody? Any of those I could throw out that don't do anything. Aiden? Beautiful. Okay, now let's go back and do a little thinking. So over here, so the Zn2 plus, throw it in some water. And see what happens. Okay, over to Feeney. Remember what's in water, so which part is it going to grab onto? Beautiful. So, how many will it grab? Yeah. And so what will be left over floating around? You got it. And for grins, I can put a 2 there just to balance it. But anyway, the important thing is you realize, so that'll make the solution Feeney what? Acidic. Got it. So it's another acidic salt. And let's see if that's okay. Okay. All right. Good. Good. All right. Let's do the next one. KClO4. Give me the cations and anions. Louisa. Good. Louisa, any I can throw out? That's from a strong acid. Ellie? Oh, that's from a strong base. What will be the effect on the pH, Ellie? Neutral. It's a neutral salt. It doesn't do anything, just like NaCl. Ute. Next one. Anthony, you're up. Give me the cation anion. Good. Okay, so I can only throw out one. Now it's time to think. So I'll let it over here. PO4 3 minus plus water. Okay, now how about to Penelope? So Penelope, what's this going to grab out of the water, the PO4 3 minus? Well, that's also negative. H, I've got the H plus, won't it? Just think water is H plus and OH minus. So it's going to grab some H plus out of here. It doesn't matter how many. We can just do one. HPO4 2 minus. Or you can have it grab 3. It doesn't matter, gang. Whatever you want to do. But the important thing is, because she had me put an H plus on there, then Penelope, what's left over? Making the solution what? Basic. Now, my people, I want you to just pause for a second. That's a really important tool that you've learned. Think about that. You can take any chemical that's a salt, which is a lot of chemicals we use in our society, and know how it's going to affect the pH. That's really important for body chemistry. Really important if you're thinking about medicine or anything else. That's really a great tool. That's for every salt available. You can do them all now, because all you need to know is what spectators there are to throw out. Isn't that cool? That's a big, powerful tool. You are now chemists. You're not just chemistry students. You can take a chemical and tell someone what it will do. I wouldn't want to put this in my blood because it's an acidic salt. Or this should make the body slightly basic if I have it in this medicine. You can do that with any salt. That's pretty cool. Okay. Questions from you or the folks at home? Whoa, I almost turned them off there. I want to do that. Yes, exactly. Bella, you can write it that way as well. She put 3 H pluses on there. And of course, then you'd have OH minuses left, so it'd be also basic. Good. Questions from all of you? Okay. What if it's amphiprotic? Okay, an amphibian can live in water or on the land. Amphiprotics can act as an acid or a base. Let's give you an example. HCO3 minus plus water. And HCO3 minus plus water. Okay. Exactly, Bella. She asked if you figure out if it's acidic or basic based on what's left over, H plus or OH minus, and that's exactly right. Okay, you ready? Here we go. Let's have this guy. Well, do the first one like normal. Like, Ellie, what will this probably take off of the water? H plus. So now I get H2CO3 plus, and what would be left? You got it. Now, turns out this guy can also do the opposite as well. So instead of gaining an H plus, because it's got 2 of them, it could also lose the second one. So who's following? If it loses, what am I going to get on the other side? if it loses the second one, that's Sophie? You lose it, that's H plus. Yeah, we're gonna lose that H. Oh. So Aunt Sophie's taken off the other H plus, and now it's gonna be more negative. That's why charge is important. And you know the charge on carbonate anyway, because we memorized that. Okay, and that H plus will probably do what? Can you guess, Aunt Sophie? Super, it's gonna make the hydronium ion, won't it? It'll gather onto the water. Pardon me. And remember that, that's another name for acid, H plus. So that makes it acidic, this makes it basic. Well, who wins? I'm going to show you how to figure this out. Okay, ready? Here's the Ka. No, the Kb. So if you're given the Kb and Ka, you can do this. This is 2.3 times 10 to the negative 8. And the Ka is, for the other reaction, 4.7 times 10 to the negative 11. Let me make sure those numbers, well, these poor people can't see it then. Okay, and I got a question from Bella. The top pardon me, Bella. The top reaction, this chemical, the HCO3 minus, takes an H plus off the water, gives off an H plus, so it becomes CO3 2 minus, and then the H plus attaches to the water and makes hydronium. The reactants, Bella, are the same, but I have two different products. And now, importantly for Bella and Astrid, they've got to see the numbers. Okay, so, and for you guys too, the Kb is 2.3 times 10 negative 8. The Ka is 4.7 times 10 to the negative 11. Okay, quite simply, which number is bigger? Which number is bigger? I got 3 n's, 4 n's. Alicia? The Kb. So the Kb is greater than the Ka, so the Kb wins. And therefore, it's going to be a hoo-hoo solution. A hoo-hoo solution. What do you think, Penelope? Basic solution. Here's a fun fact, okay? Whenever I'm in the US, I buy these things called Tums because they're like an antacid for your stomach. You ever been in the States and buy these little things? They're like kind of like kill candies. Okay, so an antacid Tums contains NaHCO3. That's the salt, isn't it? Look at that, I got a positive and a negative ion. And now you know, because you've done the chemistry work on it, why that does what to your stomach. Why do you take it for your stomach? Anthony? No, it's about acid base, not about
Does it make your stomach more acidic?
Which one? Which one back here, Errol? Okay, remember we figured out for this chemical, like this stuff, the HCO3 minus, this stuff is what's in the chemical, right? This chemical is in my Tums. So my question is, when we ran the numbers on it, Earl, we got the KB and the KA, which one was stronger? Which one wins? Oh, okay, good. So when I put that in my stomach, what will a basic thing do? Yes, or make it your stomach less what? Ah, that's how antacids work. They're basic salts that absorb acid. So Tums contains and again, I find that to be pretty cool. You've explained how a typical household medicine works. Ellie. Okay. Sometimes if you're really upset or you have naturally just stomach problems, your stomach produces too much acid. And if your stomach's really upset and produces a lot of acid, it can produce so much acid that it eats through the walls of the stomach. Not good. So people who have ulcers and other problems with their stomach will take these mild antacids like Tums to reduce the acidity or to make it closer to a neutral pH, or at least less basic. Sorry, less acidic. Less acidic. So we absorb some acid by adding a basic salt. Now, be right with you on something. You wouldn't want to take NaOH, okay? Because that's strong, right? And that strong would damage your skin on the way down and as well as you. So you want something milder. This is a mild, weak base. And so it neutralizes your stomach a bit, right? Neutralizes your stomach. And so, Pete? No, that's usually something different. Like if I'm throwing up, there's something my body's fighting, and that's more of a biological question. This is more like a condition of the stomach, like maybe you just have, I don't know, a lot of anxiety or whatever, and you develop ulcers in your stomach. Some people get this, and it means there's too much acid in your stomach. It doesn't make you throw up. It makes you feel like you have what we call heartburn in America, heartburn. And then you would take something like this to reduce that acidity by neutralizing your stomach a bit. Good. Any other questions from you? Okay, let's see if I got any online questions. I do. Okay, the top and the bottom reactions. Okay, so oh, you already asked that. Okay, so I hope you got it now. So one absorbs an H plus and one gives it off, Bella. Okay, all right. Anybody else? Okay, then let's just wrap up. Hallelujah, brother. Good. How we doing? Good. Okay, now, for the rest of our time, I'll tell this to folks at home as well. Okay, good. She got. Do you have now some questions in the book? If you do, this is a good time to ask me. So anything in chapters, whatever, 2, 3, 4, that you want to ask about, now's a good time to do so. And folks at home, I'll give a page whenever they ask me stuff. And let's see what we can get done. And Sophie has one. Yes. Yes. So you can decide when you want to take the AP test. I have a number of you who've told me you want to take it in early May. So I am getting you ready as a group for early May. But if you want to take it either in later May or in June, feel free to do so. Okay? That will be fine because you have a number of APs, a lot of you. And if you want more time to study, you can arrange, I think, still to take it later. So if you want to do that, I know Mr. Blessman's telling the same thing to his physics students. So whatever you want to do, I will try and prepare it so you're all ready for beginning of May. But if not, then whenever you take it, you're going to take it. Okay? Yeah. Anthony. Well, you don't tell me. You got to tell the AP people. So you've got to somehow register with them for when you're taking it. Alex.
I think I already did the class that for one class, one subject, everyone can one student can't just choose this one. I think the whole class has to all do one.
I don't think that's true, and I'll tell you why in a second. Louisa?
We got an email about that, but they decided that we're doing it in person. We're doing it
Like,
in
we can't decide.
In
We
person?
can't decide, the school decides if we do it online or in person, and we got an email with all the new dates for the in-person test. You don't understand.
It's like the majority type.
I'm not sure I'm very comfortable with that. What if a student gets sick?
So they get this, makeup testing anyway.
See?
There's always makeup testing.
Exactly. And those makeup tests will be the end of May or June one or the other.
So what are we registered like for as of now? For in person? Yeah, it's May 7th.
Okay, so I will do this. Again, let's research this. You know who I want you to ask about this? And I will ask him too, is Mr. Blessman. Because he's got a bigger handle on this than I do, okay? So I'll try and ask him, and you try, and if you see him, ask him as well. So if you don't want to take it, I believe you can just say, I'm not feeling good today. I'm not telling you to do this, and you could just take a makeup test. You know when I would do this? If I had a whole lot of APs in a few days and I wanted to spread them out more, I would do that. But let's ask Mr. Blessman and find out, okay? Thank you, Alex, and everyone for your perspectives. Maybe that's the way they're calling it as a school, but I'm not sure I'm all that comfortable with that because I thought there was a lot more flexibility in it this year. Okay, let's find out. I'll try and to talk to him today, and then I'll see you tomorrow about this as well. By the way, I assigned an AP classroom test this week, but it's only going to take you 12 minutes. It's on chapter 2 on equilibrium. Review that stuff. It's all multiple choice. I did it so we could try and do, like, not have the multiple choice take more time, you know what I mean? And then you had less time on the FRQ. So next week, then I'll do some sort of FRQ problem for some sort of quiz. Okay? So this will be only like, I think it's 6 multiple choice. We got 12 minutes. Study the chapter first, do it. I'm going to give you half the points just for doing it. So please do it. Don't blow it off. And then as many as you get right, you get right. And I hope it's a lot because that would be nice. I tried to put in some easier, some harder ones, and I tried to cover a lot of the ideas in chapter 2 from our book. Chapter 2. By Friday, like 6 p.m., I think is the deadline. Yeah. The chapter 1 quiz? Yeah, I didn't easily have a way to look. I could do it here, but probably not this second. I didn't have an easy way to pull and show you the multiple choice and what the answers were there and why. So all I did is I wrote down, as you remember, and we went through the FRQ. Can you look now at that old test now that you have the results back? Yeah, so look at them and then, Anthony, look at them and ask me questions in an email. Okay, how did they get this? And that I can do with you. Okay, use me as a resource. I'm happy to help you. When are we scheduled for as a class? Question from Bella, page 233, number 2. Let's do it. And Bella, I'm not sure I understand your question. Go ahead and write me that again, and I'll try and answer it in an email. And Oscar, I'm not sure. I guess early May is when we're scheduled as a class. But let me talk to Mr. Blessman about this, and I can talk to you more tomorrow about that. And we'll find a time for a Google Meet as well. Just send me some items, options. Okay, Bella, page 233. Number 2, and Sophie.
The college board says that the students are actually
Yeah,
that's the statement that presentation on the their part links right to us. It keeps working with our assignments to administration to work with. So it's just like because they don't want like students to be like, oh, I don't want to do this and like they don't want that they want to like in the open block of work to say there's too many people who are taking this exam at this stage because we don't have enough classes for this, then they move students to take in
okay.
the material.
Let's find out, and we'll revisit that question tomorrow. Thank you for coming up with this. Okay, here we go. 233, number 2. Everybody turn to that. Describe a process to remove Br minus SO4 2 minus and S2 minus from a solution. So we want compounds to add. And order. Okay, so my people, this is based on the solubility rules. Some of you might have done this one already. So based on page 229, and who has this one? So what can I add first? Give me a chemical to take out the Br minus. How about Alicia? AgNO3. So here we go. Now, everybody out there, which part of that is a spectator? Anthony? Okay, so you know it's all about the Ag plus, isn't it? So if I look at the chart, and I look and I find Ag plus and bromide, I'm looking at this rule. Here, I'll show this back to Bell as well. In the middle of this chart, I find bromide, and if I had Ag plus, it's going to precipitate it out. So that would definitely work. So takes out Br minus. Why? Because the Br minus is going to grab on here, and I'll get a precipitate of Ag Br. So that's the deal, Bella. So I can pull that out. So now I've got these two left, sulfate and sulfide. So we got to look for a difference on our table of solubility. There's sulfide and there's sulfate. Well, sulfide has some solubility. Wait, okay. Okay, all others. Okay, so sulfate and sulfide. So the alcohol, so those will be soluble, the others are low soluble. Okay, I'm going to go back and ask again. Alicia, do you have a second one to take out either one of these two? She had calcium. Okay, so let's see why she added calcium, Ca2 plus. So on that table, sulfate, look at that. Sulfate, if it meets a Ca2 plus, it precipitates out. It's low solubility. For the sulfide, with sulfate, the sulfide, when it meets a Ca2 plus, it's soluble. So we'll take out the sulfate. So to be honest, this question, and we had a similar one, Bella, on an AP test about 2 years ago, is using rules to pull things out by their differences. And
What's the AG?
yeah, I was looking at that. The SO42 minus, if it meets the Ag plus, that's soluble. So it's not going to make a precipitate. Let me look at the S2 minus with you. So that means it won't make a precipitate. So the only one that will make a precipitate with the Ag plus is the Br minus. Like the other ones, it won't do anything, so it'll just take out the Br minus on it. Okay, hold on. So let's take up that. When we get CaSO4. So we're going to have precipitates of AgBr and CaSO4. Then, Chelsea, question or comment? Exactly, it does with the sulfate, so it will not precipitate out there. Where it will precipitate out, if you look up above, it's the Br minus. It's low. Ooh, it is. Okay, all others are soluble. It's low for that. Oh, wait a minute. Okay, let me just think about it. It's low. No, okay, so we'll take the Br minus out if it's low. So I'll get a precipitate there. But I'd also precipitate out the sulfate as well. Is that what you're saying? Yeah. Okay. So which may be okay. Let's think about it. Now let's think about the question. Do you have to take them out one at a time? Individually. Okay. So I liked your suggestion, but the problem I got with it, Alicia, I think it's going to take out two at once. Ah. Good. And CU? NO3 or NO3 too? So Cu2 plus. And that takes out? And then you do the third one, right? And the third one she does is the AgNO3. And that takes out the Br minus to make AgBr. The one on the AP 2 years ago was about 2/3 as hard as this. This one's a fairly hard one because Alicia and others had to figure out the order and it was challenging to do so. But for two, it's not as challenging. You can see which one to put in first and which one to put in second. Now, Alicia chose nitrate because it's a spectator, right? Is there another one she could have chosen instead of nitrate? She could attach what on here as well? Do you know another spectator you could have thrown on there? Probably like Cl minus, I think, as well. You know what I mean? So it didn't have to be nitrate, but nitrate is a really good one because it's almost always soluble. So it's a good choice. Okay. Good. This is also the problem on the next page, problem 2. Yeah, so for the next page, if you look at the quick check on page 234, number 2 is pretty much identical. So you could use the same method that Alicia has described and also describe it there for the quick check on the next page for number 2 as well. Pretty much the same darn thing. Thanks for your help, Alicia. Good. Other questions from folks here or folks at home? Penelope.
It's in the
239.8. Okay, page 239, number 8. Let's move our folks at home over so they can see. And oh, it's going to be very similar. So we want to remove Cr3 plus, Ca2 plus, and Mg2 plus in order. Now it doesn't say in order, individual. In other words, same kind of problem. So one at a time, just like we did on the last one. Be sure to state the compound you would add and how you would remove the precipitate from the solution. For each reaction that occurs, we had a net ionic reaction. A very good question indeed. Okay, let's go back to our rules, everybody. So we're talking about page 229 again. Rules will help. And let's just kind of look at them. So chromium, and then calcium, magnesium. So we want something with anions to do something. Well, again, we got a difference in sulfate and sulfide. That might be useful. And we got a difference in, well, let's see, the halides, the Cl minus and stuff, going to be the same. No, that's going to go out. Okay, so I'm going to open it up to you guys. So give me one I can remove first and give me a chemical I could do it. Chelsea. Yeah.
NaS?
Yeah.
Or Na2S?
Na2S. Okay, so Chelsea's asking me to add some S2 minus. Let's go down and look at that. So S2 minus, she's got Mg2 plus and Ca2 plus that are soluble, so those are still going to be in there. And the others, it says all others are insoluble, including chromate or chrome 3 plus. Beautiful. Good work, Chelsea. So that removes and now somebody else, what would be the formula? S2 minus and Cr2 plus. Can you make me the solid formula for that? Can you balance it out? Yeah, Alicia, go ahead. Good. Now, let's do a net ionic reaction. I'll give you the end of it. What Alicia just gave me, that's the solid. Who can do the other side? Aiden.
S2 minus plus CR3 plus.
You're halfway there. Now you got to balance it as well, Aiden. Look at your subscripts and tell me.
3S2 minus
Beautiful, and?
CR3
Nice, good. Thank you, Aiden. And I want all of you to feel confident in doing that. How do I know I don't have to put in the Na plus? Because it's a spectator. Jesse, please go ahead. Good. Use the same thing, it doesn't matter.
Oh, yeah, or the same thing, and then to,
Yeah, she's just adding a spectator to round it out, isn't she? You could add Li2, I think you're saying that, or you could add K2, it doesn't matter. Removes, and now go for it, Chelsea. What would you be getting out there? The Mg2 plus? Ca2 plus. So I get Ca2 plus. And now over to, how about Alex? So if I'm removing that, and there's my sulfate, what's the solid that's forming? Yeah. So I can do the net ionic reaction. This one's a little boring, isn't it? Okay. Aqueous, solid if you want. Anyway, yeah? Good. And the last one, we got to be able to remove, let's see what she did. She put in the sulfate, and that separates, so I still got Ca2 plus, and now I can put in what? Somebody else want to take the last bit? How could I pull out then the Mg2 plus? Mg2 plus, what could I put in to pull that sucker out? Hint, look down at the bottom. There's more than one answer. Aiden.
Sulfide, carbonate, or phosphate.
Good. How about carbonate for fun? Could we add Na2, CO3? Okay, thank you, Aiden. And thanks, everybody. We'll see you tomorrow. Thank you, Bella. And yeah, good. Good. And write me questions, and Oscar, write and ask me when you want to meet. Happy to do so. Send me a couple times. Whew. Goodbye, Rita. Today's 13. Goodbye. Thanks, man. You too. Goodbye, Anthony. And me was missing too. Okay. Yeah.
Have a nice day.
Thank you. You're welcome. You're welcome.
Oh, and I apologize for being I had Bye.
tomorrow, is my ever
I think we're in 305 for Total physics, and then again, huge mark at or AP. Okay, see you guys. Bye-bye. Yeah,